Welcome, everyone. Thank you for joining today's session on Cyber Resilience Act risk assessment. What do I need to do? Before we begin, let me briefly introduce today's speakers. My name is Andreea Scarlat, and I'm a senior cybersecurity coordinator at the Romanian National Cybersecurity Directorate, and also the project manager of the Cyber Resilience Act Artificial Intelligence project on the DNSC side, and your host for today. Joining me is Connor McGovern, Chief Technology Officer at the CyberCert Labs. His presentation will include an overview of the Cyber Resilience Act, a walkthrough of the tools developed within the Cyber Resilience Act AI project for SMEs, as well as a practical look at cyber risk and risk assessment processes. Finally, we are also joined by Răzvan Gavrilă, Head of Sector for Market, Technology and Product Security at the European Union Agency for Cybersecurity. He will sharing with us the EU-level insights and recommendations on Cyber Resilience Act implementation. This webinar is hosted by the National Cybersecurity Directorate, or DNSC, and it's part of a broader effort to help organizations understand and prepare for the requirements introduced by the Cyber Resilience Act, or CRA. Today, our goal is first to explain the role and growing importance of risk assessment when it comes to compliance with the Cyber Resilience Act. Second, to give you practical insights and expert advice on how to identify, evaluate, and manage cybersecurity risks for digital products. And finally, to outline the key steps and tools needed to ensure your products are secure by design and by default, as required by the regulation. Let's explore how you can get started and how AI-driven tools can support you every step of the way. Let's take a moment to clarify what you can expect to gain from this session. Okay, sorry. By the end of today's webinar, you will walk away with a clear understanding of the risk assessment requirements under the Cyber Resilience Act, not just what the regulation says, but what it actually means in practice. We will also be sharing best practices and methodologies recommended by key players like ENISA and CyberCert Labs, so that you're not starting from scratch, but building on tested frameworks. You will receive practical guidance on how to identify, evaluate, and mitigate cybersecurity risks in a structured and effective way, especially when it comes to digital products that are in scope for Cyber Resilience Act. And finally, we will wrap up with the key takeaways to help you prepare your organization and your products for Cyber Resilience Act compliance. Whether you're just starting or refining your approach, this session is meant to give you clarity and direction, we hope. So, why should you be interested in the Cyber Resilience Act? First, the regulation is approaching, and it's comprehensive. If your business makes or sells digital products in the European Union, there's a good chance it might affect you. Second, the stakes are high. Non-compliance can result in fines or loss of market access. But more than that, there's reputational risk and operational disruption. The Cyber Resilience Act is not just a legal box to check. It's about building trust with your customers and ensuring your products are secure from the ground up. Let me now briefly introduce you the project behind the webinar. This is a Europe-wide collaboration bringing together cybersecurity experts, public agencies, and SMEs themselves to simplify the CRA compliance. Our goal is to remove as much of the complexity, uncertainty, and cost as possible, and to replace it with practical AI-supported tools that guide SMEs through the process. From assessing risk to understanding how to prepare for a conformity assessment, we want to make sure that Cyber Resilience Act compliance is within reach, not just for large companies, but for small and medium-sized companies as well. Now let's meet the consortium partners of the project. CyberCert Labs is the project coordinator and leads the development of the Cyber Resilience Act artificial intelligence platform. Refracted Security focuses on improving vulnerability management and integrating secure code analysis and penetration testing. ZIPO is in charge of creating CRA-specific training modules and embedding them into the platform. Going further, we have NRD Cybersecurity, which is acting as a pilot SME, testing the platform with 2 real-world products to validate its effectiveness. After the National Cybersecurity Directorate, or DNSC, which leads the communication effort, including webinar like this one, and engages with the stakeholders across the Europe. Finally, we have Red Alert Labs, which supports the pilot phase and helps define the technical artifacts needed for successful CRA conformity assessment. Each and every partner brings real-world experience to make this platform practical, tested, and aligned with actual CRA needs. Going further, Connor, if you can make the overview of the Cyber Resilience Act, and just to mention, if there are any questions, you can address them by raising the hand, and we will let you speak, or putting them in the chat, and we will see them after and respond to them. Connor, please. Thank you.
Thank you, Andrea. Yeah, just a quick overview of the Cyber Resilience Act for those that may not be as familiar with it. It's a regulation that was signed into law in December the 11th, 2024. And unusually, it actually has a 3-year transition period. Normally, it's a 2-year transition period for regulations of this nature. But the impact analysis for the CRA, when the Commission conducted it, as it's required to do before introducing any new regulations, did point out that it's a significant step up for digital product manufacturers. And they specifically called out the impact on small to medium enterprises. So that's why the Digital Europe program has funded projects like CRA-AI to help produce tools and methodologies and assistance to SMEs to navigate the CRA. The CRA, it applies to products with digital elements that are made available on the European single market. What does that mean? Well, that means if you place for the first time your product on the market and sell it to a customer within the EU, it's deemed to be available on the market, and that means that you're subjected to the requirements around the Cyber Resilience Act. We're all very familiar with the CE mark on products that we buy, electrical products, home appliances, and so on and so forth. Often those CE marks are attesting to the conformance of those products to health and safety standards, to recycling standards, so other standards that kind of exist. What's new about the CRA is that it will require the digital product manufacturers to affix a CE mark attesting to the cybersecurity capabilities and controls within the product, meaning that it's safe to use from a cybersecurity point of view. It's timely to mention standards because underpinning the CRA regulation will be 47 standards in total. Some of them are horizontal and some of them are vertical. At the moment, there is a working group working on some of the foundational horizontal standards that will be available next year in 2026, roughly around October 26, with the remainder of the standards coming in 27. The vertical standards, some of them will be specific to product categories. So within the CRA, it makes a distinction between lower risk product categories. So when we get into the risk assessment, we'll talk about this, and then the higher risk categories. So those vertical standards will address specific product categories. What does it in a nutshell mean? It means as a product manufacturer, you carry the liability for ensuring that your product has the right kind of cybersecurity embedded within it, depending on what the product's intended to be used for and where it's intended to be used. And we'll delve into that in the risk assessment. It brings the concept of security by design and by default. So that default piece is important. What does that mean? Well, security is designed into the product from the start, and that by default, that security is turned on. So I, as a consumer, when I buy a product, I don't need to do anything special or specific to enable the security features within the product. They are turned on by default. So that's it in a nutshell. Good to note the second bullet point towards the end there. The requirements about vulnerability reporting, they will come into effect in September of next year. So that's quite a specific part of the CRA, which deals with reporting to CSIRTs and ENISA any vulnerabilities that are discovered in a product when it's on the market. Not before, but when it's on the market. And there's other requirements around telling customers and providing advice about how to update the product so that it's not vulnerable. So that's the CRA in a nutshell, Andrea. So as part of the CRA-AI project, we have Am I in Scope tool. You can follow the link to the URL here and register. And when you enter the CRA scope assessment, you can conduct that for free. It's a series of questions to help you understand if your product is in scope for the CRA. So that's the first thing to think about if you're a digital product manufacturer. Am I in scope? So for example, there are certain product categories that are descoped because there's already existing standards for the cybersecurity in those products. Or it may be that your product is, for example, a pure software as a service product, which is also not in scope for the CRA. Also, if you contact the DNSC after the webinar at the email address on screen, and we'll remind people at the end, you'll also get a free code to conduct a free readiness assessment. This is roughly about 30 questions across a number of categories, and it's intended as a simple way to actually figure out how ready you are for the CRA. At the end of the process, you get a nice report that breaks down based on those sort of areas where you've got things in place and where you've not got things in place, some advice about how to go about getting yourself ready. Also in there is an SME guide to navigating the CRA, which you can download. That's a PDF, which kind of breaks down some of the terminology within the CRA, tries to explain it in more accessible language. So that's a nice guide to have alongside the readiness report. So we're doing this in order to help SMEs kind of get to grips now with what they will need to do for the CRA. Because while it might seem 3 years is plenty of time, there's quite a bit in the CRA. So the sooner that you start to actually figure out what do you need to do and how far away from being ready, we would strongly encourage people to go and take the readiness assessment. We also have an early adopter program. So Andrea mentioned that we're developing an AI-powered software platform that's designed to help support SMEs throughout the whole journey. So from the planning stage of planning to bring a new product to market, through product design and product development, and also through the release of the product, because there's a lot of new requirements around customer documentation, for example, and then the maintenance period of the product. So while the product is on the market, to be able to support it in terms of things like, as we discussed, vulnerability reporting. We will have our minimal viable product of the platform available towards the end of the year. So we're looking for early adopter customers if you want to come and help us test the software, give us your feedback. We'd love to have as many SMEs across as many different product categories in that program to help us actually make the software fit the needs of SMEs. So you can, the URL is there in below the sign up as an early adopter. If you want to go there, you can sign up as an early adopter.
Thank you very much, Connor, and we will talk to you a bit later. Now, Razvan, the floor is yours. Thank you.
Thank you very much, Connor. Thank you, Andrea. So I'm going to quickly take you through some of the elements related to the CRA. Some of them have already been touched upon by Connor, but also I will quickly focus on some of the tasks that our agency has been assigned within the context of the CRA. Okay, I assume that I have control over the slides. Is that correct, Andrea?
I moved them, but if you want to share your screen, that's okay.
No, that's fine. So can you please go to the next slide?
Yeah.
Thank you. So first of all, something that I need to mention, and I have this line every time when we do a presentation on the CRA, is that the Cyber Resilience Act isn't just another piece of cybersecurity legislation. Actually, quite a few has been pushed in the last couple of years. We have the NIS2 that many of you may be familiar with. We also have the Cyber Solidarity Act. Before that, we have the Cybersecurity Act, which is also the founding act of our agency. Nevertheless, the CRA actually marks a fundamental shift in what the expectations are in Europe when it comes to security of the products we use every day, on the products that we have on the EU market. And that's because for many years, the focus was often on securing either networks or reacting to breaches and security incidents. What the CRA brings in and what the fundamental change is that there's an expectation that security needs to be embedded in the products themselves right from the beginning. And I have here a couple of elements that I mentioned. One of them that we often hear or we talk about is the shift of security towards the left. The first major change that came with this piece of legislation is the principle of security by design and by default that was also mentioned a few moments ago. And that means that manufacturers can no longer treat security as an afterthought or as an optional add-on. And we will also touch upon that point during the course of this webinar. So there's an expectation from these manufacturers. They are legally required to build security into their products, both hardware and software, from the earliest design stages. And also they need to ensure that those products are configured securely out of the box. So this is a proactive approach, and the aim here is to address potential vulnerabilities even before many of these products reach the market. So you as a manufacturer, you have a responsibility to check whether at least to the maximum level of due diligence that you can apply, that any weakness or any vulnerability that it's available in, that it can be identified in that product is fixed before the product reaches the market. Then there's an element related to manufacturer accountability that it's strongly linked to what I mentioned. Probably this is one of the most significant shifts, and that is that there's a direct legal accountability that is squarely placed on the manufacturer, importers, and distributors. So in case the manufacturer is somewhere else outside of Europe, they are all responsible for ensuring the products that they place on the EU market meet the CRA security requirements, and also they are responsible for ensuring that those products went through some form of a conformity assessment. And non-compliance can lead to substantial fines and also market withdrawal orders. That means that also manufacturers have here a responsibility towards transparency. They need to report actively exploited vulnerabilities to our agency, and our agency afterwards is responsible for distributing that information to the CSIRTs, members of the CSIRT network. And I would like to underline here the word exploited. So not all vulnerabilities that are detected by the manufacturer, but those that are actively being exploited. Then there's another element that the CRA has recognized in terms of the importance of cybersecurity, and that is that cybersecurity doesn't end at the point of sale. Manufacturers are responsible for the security of their products throughout a big chunk of that product expected life cycle, and there's also a cap there of at least 5 years. So that means that any manufacturer is responsible for providing security updates and patches for that time frame, and also they need to have tangible and clear and well-defined processes in place to manage vulnerabilities after that product has been sold. The good thing about that is that the legislator aims to put an end to the so-called sell and forget type of model. And also, I think we have seen in practice cases where such functions as being able to update your product was sold as an add-on instead of having it there in place by default. Also, the Act pushes for a greater level of transparencies. Manufacturers need to provide users with quite a lot of information about the security features of their products, including the supported period for security updates, as I mentioned. They also need to have clear channels established for receiving vulnerability reports from third parties. And also, they have some vulnerability disclosure obligations. As mentioned, for example, in the case of exploited vulnerabilities, using the single reporting platform that our agency is currently establishing. Also, maybe something that it's good to mention here, unlike previous regulations that might target specific sectors like finance, the case of DORA, or critical infrastructure, if we think at the NIS Directive 1, the CRA applies horizontally to nearly all products with digital elements sold in the EU. There are very few categories that do not fall under the CRA, for example, medical devices, cars, products used for national security purposes. But in general, if it has software in it, most likely it falls under the CRA. So everything from smart home devices and toys to industrial control systems and standard software that you're using or that the organization where you're working is most likely using. And the interesting side effect of that is because the EU is such a large market, this will most likely have a very, very significant global implication, as any company worldwide that would like to sell digital products in the EU must comply. So there might be a percolating effect of the CRA across the globe, not only in Europe. Also, something that I think it's left out often is that before the CRA, cybersecurity requirements for products in terms of what the expectations were from national authorities could vary by quite a bit. So that meant that there was a rather complex patchwork for businesses. The good thing about the CRA is that it can establish one clear harmonized set of essential cybersecurity requirements across the entire EU single market. So this means that the end effect is that this will provide some legal certainty for businesses and also will ensure some consistent level of security for consumers and businesses across all EU member states. So may I ask you to go to the next slide, please? Thank you. In terms of our role as an agency, we act as a technical hub, and the legislator is expecting us to be one of the primary facilitation points for the effective implementation of the CRA across the EU. We have there a couple of core missions. One of them is obviously provide expertise and guidance. This is also something that it's embedded in our founding act, in the Cybersecurity Act. And we are expected to deliver specialized technical knowledge and strategic guidance, basically to help others navigate the complexities of product cybersecurity. And this is obviously something that our agency has been doing for quite a bit of time. We've been around for more than 2 decades now, and we've been issuing such best practices and guidance for quite some time. Then, when it comes to the key actors that we need to support, obviously one of the key stakeholders here is the European Commission that we need to help when it comes to technical advice during policy development. This is an active role that we've been playing for quite a number of years now. Also, we have a couple of dedicated tasks that I will mention in the next slide in relation to market surveillance authorities and also computer security incident response teams at national level and how we support them in their operational duties, in particular through the setup and operation of the CRA single reporting platform. And also when it comes to harmonization, we do play an active role in the development of standards. And again, this is something that we've been helping our colleagues from the Commission since the request to the ESOs has been placed for the standards that will support the CRA. And also, obviously, we play a major role in the certification space where we do have a very, very clear mandate. So perhaps we can go to the next slide, please. Okay, I'm not going to go in detail to all the legal articles that have assigned various tasks to us, but I'm just going to mention a few of them because I think they are quite essential. Our agency is expected to assist the European Commission in the development of the harmonized standards for cybersecurity and those that will support the CRA. This is something that we've been doing for quite some time now in our capacity as a technical agency. Also, we have an obligation to promote the use of the European Common Criteria-based Cybersecurity Certification Scheme, the UCC, for critical products with digital elements. Actually, our colleagues from the Cyber Certification Unit have released a study in February 2025 on the mapping of CRA essential requirements to EUCC. They will be running a couple of pilots this year for this purpose. I think this is a very interesting piece of work that already shows good signs of good promises. There have been 2 webinars. And if you go on the certification.enisa.europa.eu, you'll find there the link to the recordings. I think they are quite interesting. So if you would like to know more about the link between EUCC and CRA, that's a good place to start from. Also, something that might be of interest to some of you is that market surveillance authorities, when they will be established at the level of the member states, may request both to their national competent authorities, to their cyber agencies in principle, also to our agency, technical advice on matters related to the implementation and enforcement of the CRA. And also, in relation to these MSAs, to the market surveillance authorities, we may identify a category of products for which simultaneous coordinated control actions, basically market sweeps, should be organized. And in relation to operational bodies and also crisis management bodies, obviously, we operate the single reporting platform in close cooperation with the CSERT network. And this is probably going to play quite a big role in assessing the success of the CRA. And also, under specific circumstances, our agency may submit to the European Cyber Crisis Liaison Organization Network, the EU Cyclone, information, if relevant, for the coordination of and management of large-scale cybersecurity incidents and crises at operational level. So this has been quite a lot, and I'm going to stop here. And maybe we can go into the main content of the webinar today. Thank you.
Thank you very much, Razvan. So why the CRA, Connor?
Yes, and maybe just before we leave ENISA, I don't know, Razvan, did you want to mention the ENISA threat landscape reports and some other publications that you guys produce, which I find personally really, really useful as resources for things like the risk assessment?
Yes, thank you very much. And actually, I'm very happy that you have shared this particular slide, because I think often we we kind of ignore why the CRA was put in place. There's quite a lot of talk about the burden for many of the manufacturers when it comes to implementing the CRA. But the original intent of the CRA was not only to solve incidents, but was also to help businesses spend less on cybersecurity. I see there, for example, Mirai. Mirai has been around since 2016, so almost 10 years now, and it's still active. It's still present. It's still being used in large-scale DDoS attacks. We had, I think, maybe 1 month ago, one of the member states' financial sector being targeted by this particular botnet, and a good chunk of the e-banking in that country was impacted by this particular activity. Then I see some elements related to ransomware. We had cases where providers of software that were being used by managed service providers. So I'm talking about companies that were providing IT services that were using specialized software for that purpose. In the context of a supply chain attack, those components were targeted, and it enabled ransomware gangs to infiltrate many organizations. We have more recently ORP networks that are being abused by APT actors, and even something as simple as SOHO devices that we see many telecom operators, they spend a lot of time. There's a small echo. Thank you. We see telecom operators investing a lot of effort into securing products coming from manufacturers, implementing security defaults, just because those manufacturers do not go through this process. And I can tell you, even from my own personal experiences, it's sometimes very difficult to get from software developers a clear indication of what were the security controls they have put in place in the software they have developed for you as a customer. And also, it's sometimes quite challenging to explain why you need to have, for example, multi-factor authentication in case of a system that will be processing sensitive categories of personal data. So the CRA has been put in place to help both business users and also average consumers to no longer spend that much time in securing the products they have bought. This is one of the problems that the CRA is trying to solve, and most likely will succeed in solving. So it's not only about the manufacturers that will bear the burden of securing their products. It's also the unloading of this effort that many businesses and consumers had to do when they were buying some of these devices from the market. Thank you.
Thanks, Razvan. And yeah, I think that's an interesting point, because I think what the CRA is doing is it's sort of equalizing the liability scale. So it's making product manufacturers liable for the security within their products, so that when they're purchased and then placed into an operational environment, whether that's in a personal or in a corporate setting, that entity is not having to think about, well, how do I secure this product that I've just bought? And sort of, if we look at some of the issues there, and the amount of time and money that particularly regulated entities under things like NIS2 and DORA spend just patching systems is really significant. So if we could redirect that spend from literally updating products because they came with vulnerabilities, that because it wasn't secure by design and by default, into more proactive kind of useful things, then that would really help. And it kind of makes the whole ecosystem more secure for everyone. And I guess, under the digital single market, the goal is to increase the amount of digital services that are available within the single market, but that can only be accelerated through higher levels of trust, which the CRA sort of kind of helps with. And one of the interesting things looking across here is because you've got a mixture of IoT devices, you've got OT, and for example, healthcare settings where if you buy a diagnostic piece of equipment, quite an expensive one, it may be operational for 15 years. So that support period needs to follow that product, so that if there's an underlying operating system being used to run that diagnostic system, it can't go end of life. And that's actually in the healthcare system a big problem, where you might buy a diagnostic machine for 20 million euros, but it's being managed by a home operating system attached to a normal PC computer next to it. And often that's what gets hit. When that's disabled, then the diagnostic machine stops working, and you're not able to actually perform the healthcare kind of activities that you want, which maybe leads us nicely on, I think, onto the next slide. So a lot of background material there, but kind of the whole purpose of this session is to sort of try and do a deeper dive into the risk assessment requirements within the CRA. So what's on the slide here are my definitions. So the standards have not been published that we talked about earlier in the talk, which will help to give us a standardized vocabulary for many of the elements within the CRA. But if you look to existing standards, I think for me, when I discuss risk with people, and if anybody's got a different view, as we said, we'd like this to be an interactive session. So either raise your hand, type something in the chat, or help to add. But it's useful to have a definition of risk. And in ISO 31000, which is an operational risk management standard, reflected in 27005, they define risk as the effect of uncertainty on objectives. So when we think about risk, we want to do something in the future, or we want something to happen in the future. And risks are all about what are the type of things that could make that not happen. So a level of uncertainty. So my objective may be to cross the road safely, but there's a level of uncertainty, particularly if I close my eyes, or I'm crossing when the man is red, or any of those other factors. But my objective is to get across safely, and there's some level of uncertainty about whether that's going to happen or not. And often we think about risks by considering the event that triggers the risk. So risk on its own is maybe a bit theoretical, but often risks are triggered by an event. So the risk of, or the objective to cross the road safely could be stopped by the event of being knocked over. So that's the event that triggers the risk. And then we try and understand the level of risk by measuring the impact and the probability. Some people say likelihood. I think they're a synonym for each other, impact. And I think for me, as a mathematician, probability is a more rigorous statement. But how far off my objective will I be knocked by the risk, and what's the probability of it happening? So is it a 1 in 10 chance, a 1 in 100 chance, or sometimes people talk about it in elapsed time. Will it happen in the next 30 days, 90 days, the next year? So that just gives some context. So when we're thinking about products, it'll be interesting to contextualize this in terms of the CRA. So we've got to think about product risk. And certainly for me, a lot of the industry, because there hasn't been a regulation like the CRA, has been around operational risk rather than product risk. Because when you build a product and you're designing security into the product, you're thinking about how the product may be used in the future. So it's not something happening today. You're trying to envisage how will my product use and what kind of risks will the user of that product come to. So maybe in the context of the CRA, we're talking about the probability of harm. And because it's a cyber regulation, the harm is coming from a cyber threat. It's in the context of the intended use of the product. So if you sell a product to somebody and they use it in a way that it wasn't intended to be used and they come to harm, that's not actually in the context of the CRA. On when we do a webinar on the documentation requirements, some of the output from your risk assessment ends up in the user documentation where you explain the intended use of the product. And then we think about the event that generates the harm and the measure of the impact of the harm. So if I'm using the product as it's intended, could there be an event that means that harm comes to me or to others, and what's the impact of that harm? So that helps us just place risk in the context maybe of the CRA, because it's risk can also be quite a subjective thing as well. So we have to try and ground it in some objectivity. Maybe if we go to the next slide. So The risk assessment process. So the CRA says conduct a risk assessment, and our view is that you want to try and conduct that risk assessment as early in the product planning and product design process as you can, because it's intended to have downstream use as you develop your product. So the first thing is the definition of product. And in our project, we've been spending a lot of time since the start of the year. The project began in January, trying to figure out good ways, good techniques of drawing a boundary around what is the product and then what's not the product, because that's super important. And it's more difficult than it seems, particularly if a product has multiple kind of components that make up the product as well. And also just to note, and we'll come on to this a bit later, that the CRA does include remote data processing as part of the product and product definition if it's supporting key features within the product. And we see that more and more today, that connected products have this remote data processing part of the product. So drawing that boundary, saying things inside this boundary are the product and things outside this boundary are not the product, but they are also important because they could influence the types of threats that the product may be subjected to. We need to think about the main features of the product. So what is the product meant to do? So if we were thinking about the definition of risk as the effect of uncertainty objectives, well, one of the things you could think about is, well, what type of threats would stop the product from working as it was intended? So how do I disable the product, or what kind of harm could I come to by using the product as it was intended? And then also, where will I be using the product? So what kind of an environment? We're thinking about environments such as home settings, which may be different from corporate settings, which may be different from high-risk settings, for example, regulated sectors under NIS2/DORA, but also how hostile is that environment? So is my product intended to be used inside a protected network rather than out on the public internet? So, what's my kind of operating environment? So to think about that, and then what kind of data processing goes on as part of the product? And as I said, is any of that processing remote, not directly tied to the physical product if there is a physical product? And then just thinking about what the stages are of a risk assessment. So quite often, again, this is quite generalized. You go through a risk identification phase. The risk identification is everything we've said, which is trying to think about what are all the risks associated with the product, and then for each risk, then to evaluate it, take it through a process to figure out. So usually that's figuring out the level of impact and thinking about the probability of the triggering event triggering the risk. So often people use sort of sliding scales, sometimes 1 to 3 for impact and probability, or sometimes 1 to 5, and then they plot them out in a 2-dimensional kind of grid. So things that have high probability of happening with high levels of harm, much higher levels of risk. Things that have a low probability of happening that produce low levels of harm, much lower levels of risk. And then we come on to I guess a part of this to generate some debate, because there is some difference between operational risk, as we said, and product risk. So treating the risk. So quite often in this context, in a product, we're trying to reduce the risk. That's often the main thing you're trying to do. So you're saying, okay, look, we have a risk here, and unless we do something about it, it's probably too high to be acceptable to the users of the product. So therefore, we're going to mitigate that risk by introducing security controls. So as Razvan said, if you're using a product that's processing, let's say, sensitive personal data, such as financial data or health data, you may say, well, in order to access that data, the username and password doesn't reduce the risk sufficiently, so we'll introduce multi-factor authentication. So we'll require a second factor. So that's maybe a very simple example of risk treatment. So if I just use username and password, maybe that's doesn't produce enough risk reduction, so we introduce the multi-factor authentication. And then, as we were saying, by secure by default, then I have to think as a product manufacturer, okay, so when you turn the product on, how do I enroll you for that multi-factor authentication? That's something that you're going to need to do by default. It can't come later. I don't know, Razvan, have you got a thought on that about how to manage that situation?
So security and usability, it's a very complex field, but I really like the emphasis that you put on the main features of the product, and that's intended use and the operating environment, because this can have a tremendous impact on your threat model. I imagine at that moment in time we will touch upon that. And an example that I often like to provide is general purpose computing and a gaming console, especially some years ago, where the threat model is almost completely different from the manufacturer perspective. So in the case of a general purpose computer that you would buy at home, you can obviously play games on it as well. The threat model that you may have in mind is, okay, how can I protect this device from an external threat source so the computer doesn't get hijacked? While in the case of a game console, for many years, the main threat source was the actual buyer, who would try to tamper with the device, who would try to bypass the digital rights management, who had physical access to the device all the time, who would do anything and everything that was possible to install homebrew and so on, which obviously had some serious consequences, as often such gaming consoles, they were subsidized to some degree by the manufacturer because the money was coming from something else. So this element of intended use and the operating environment, how that particular product may be targeted by a threat source, can lead to very different strategies in terms of where you'll put your emphasis on the security controls. So this is one. Then going back to an element that you mentioned, and I think that's a key concept and key term that we need to use, is that risk is not something that we can fix. Risk is something that you need to manage. You put controls in place that will target either the likelihood or the potential damage or impact, but risks cannot be just wiped off. You cannot fix them. You need to manage them.
Thanks, Razvan. Yep. And I think that's the whole concept of risk. Risk treatment. We do have two questions, so I'll answer them in order at this point. Peter's asking about SaaS services processing data. It's a really good question. So the CRA makes reference to remote data processing, but it's in the context of supporting features within the product. So you can imagine if there's a remote content management system and I'm using a mobile app and that content management system is, rendering stuff in the app, then that's possibly remote data processing because it's supporting a key feature of the app. But if it's a pure SaaS product, so I log in through a web interface and that's the entire product, then actually they're out of scope. So I think the thinking was that the SaaS products would come under the cloud kind of act, the Cloud Security Act, or a derivative thereof, that would cover purely kind of cloud-based compute services. So yeah, it's one of those areas that we're going to need to work on as a group and a community. What parts of remote data processing, because if it's not supporting, so for example, if it's, let's say, a logging and monitoring telemetry capability, but it's not actually supporting a core feature, maybe that's not in scope. Maybe that is not considered remote data processing for the purposes of the product, unless of course it's a security product and the audit trail is one of the key features. So that intended use of the product is super important to help kind of with that. So I hope that kind of distinguishes maybe between SaaS and remote data processing. And Gaziz is asking about risk analysis. Yes, I did mention ISO 31000, which is actually an operational risk standard because we don't actually have a product kind of definition of risk just yet. I thought it fit, but you're right. Risk analysis, in my opinion, is something done in an operational environment. Here, we have full control if you think about it. So when you're operationally, there's levels of uncertainty, but when you're actually building the product, you have full control as to how to build the product. So you can kind of go straight from evaluation to treatment. So you can say, I've evaluated the risk and I'm not happy with it, so therefore I'm going to treat it. I don't need to do some analysis in the middle. That may not be correct. It may be that the standard does introduce that. We'll know sort of this time next year when some of the first horizontal standards come out, which Annex 1 is a big part of kind of the CRA, just in terms of the technical detail listing, the essential requirements. But yeah, we're trying to figure, because we're trying to build a piece of software that supports this, so we're trying to figure our way through what are the actual discrete risk assessment kind of steps. So if you want to be an early adopter customer, I'll ring that bell again and come and help us with that process. That'd be great. The last piece is risk documentation. I included that because again, it's a bit different in that some of the output from the risk assessment will need to end up in the user documentation. So in the annexes, there's several parts that deal with user documentation, but just in general, essentially what you'll have to explain to the consumer, the purchaser of your product, through your associated documentation, including the declaration of conformity, will be a high-level description of the types of risks you've considered and what are the security controls that reduce those risks. One of the reasons for that is that if you provide the option to turn a security control off, and you can do that, so you could offer a user the ability to say, I don't wish to do MFA, I'm willing to accept the risks, but you need to have documented that in the documentation, so the user is making an informed decision about, if I turn that control off, what risks am I exposing myself to. So it's not a case that the security controls, when they're turned on by default, need to remain on always, although there'll be certain circumstances where you might think we won't allow the user to turn off a control because it generates too much risk. Great. Can we move to the next slide? Sorry, go ahead, Razvan. Yeah.
Just one point here, though. So when it comes to documentation, we need to flag that there is something, let's call it a challenge, that will need to be addressed to some degree, because we obviously are all aware of privacy statements and terms of agreement and all sorts of services that we click accept and we just move on. So there needs to be an element there to ensure that the moment when a user receives this documentation, it's delivered in such a way, especially when we are talking about enterprise customers, that they can understand what is it that the manufacturer has actually done in practice in order to address some of let's call them common issues that you would find in a product.
Thanks, Razvan. Yeah, and we've been thinking about this in terms of the initialization of the product and the security defaults. Maybe that's a great opportunity to reflag some of those points. You know, it doesn't have to be in a static document necessarily. It can be part of the product itself where you highlight, or if I go to turn a control off, you re-emphasize, well, you're going to expose yourself to this risk. So it can be something that you know, security, in my view, is a feature. It's not a non-functional requirement, as sometimes I see. It's an actual feature, so it should be treated as such and make it easy for the customer to understand, or the user to understand, why that feature is there and what benefit is it bringing them, even if it's making there be a little bit of friction, as Razvan said, for the login process. Well, it's worth it because it means your personal data, or you're protected from these types of risks. Great, maybe you can move to the next slide. Can we just move the slide on one? And sorry, we have a point from those. So linked with red, yep. The new CS provisions to be implemented, yeah, by the 1st of August. So that's a really good point about the radio. So I'm going to get this wrong, probably.
Radio equipment directive.
I always get confused with electronic radio equipment directive. Absolutely coming in this year. And that the CRA, I think, will repeal that. I'm not a red expert, and replace it when it comes into full effect in 2027. So just delving into the anatomy of a cyber, so trying to make this practical. So in our software, there's a couple of things we're thinking about. One is that threat modeling is a very good way to go about sort of doing the risk assessment as a really supporting piece of that. So I've got a small graph on the right hand side. So we're thinking about graph databases as a way to express a threat model, because they have nodes and relationships between nodes, which is a key part of a threat model. So we intend to sort of bring that into the software. And what that lets us do is to decompose the product into its constituent components. So how deep do you need to go? Well, that's an it depends kind of point, but certainly within the CRA, explicitly it talks about software bills of material. And I guess implicitly it talks about hardware bills of material, in that you need to know what are all the hardware components within the product. So if we spread these out in a graph, we say, here's a product, I decompose its components, both software and hardware, and I decompose them a bit further. So maybe I'm getting into what are the software libraries. I may have a major hardware component, but it may have subcomponents, subprocessors, memory, firmware, various other pieces. And we have this conceptual model, almost like a digital twin of the product. And one of the things we're considering on multiple fronts or multiple uses is that construct would be machine readable, first of all. So it can be, if it's exported from one piece of software, it can be ingested into another piece of software because it's machine readable. And that there would be some form of standard ontology, which is a high level description of the possibility of the relationships between elements within the graph, so that there's consistency. So the machine readable format will give the structure to the data, and the ontology will give the structure to the relationships. That would mean, for example, if I'm a product manufacturer and I'm producing a component that I sell to another product manufacturer, and they're including my component in their product, I can give them my threat model in a machine readable format, and they can just simply ingest that. That gives them access to what security is in my component, what kind of threats is it looking to address, what kind of risks is it offsetting. So we're trying to design our platform to be part of an ecosystem. And we'll come on to other activities and testing that will produce machine readable kind of format, so that as SMEs, you can use whatever tools you want, and you can move that data around into different tools with different purposes with different service providers, and that it's all interoperable. So we have really, really good examples. And I'm thinking in threat intelligence, for example, through Oasis, Stix and Taxi are two very commonly used things, which mean that you can move CTI or cyber threat intelligence around between different systems and ingest it, and actually, because it's got an ontology on top of it as well, you can actually connect the right things together. Everybody's calling the same thing. So just in terms of the anatomy of the risk assessment and in terms of the threat modeling, so we're thinking about risks and events. We're then thinking about, well, what threats and threat actors can trigger those risks and events. So this is kind of maybe what's slightly different about cyber when it comes to the sort of process of risk assessment, is because there's agency. So usually, not exclusively, but usually it's a deliberate action by a threat or a threat actor to exploit a vulnerability or a weakness in a system. So that's what's happening. It has agency. There is creativity. They can decide to go a different way. If one path is blocked, they can go the other path, which is different from some other maybe more naturally occurring operational risks, and they're looking for that vulnerability or that weakness. So either that's something that's been disclosed or discovered by somebody else or discovered by themselves, and they're looking to exploit that. And then as the product designers, from a security by design and by default, well, we're then thinking about what are the controls, or sometimes they're called countermeasures, to address that vulnerability or weakness. And that's sort of the sort of descending list. So you kind of go risk and event, threat and threat actor, vulnerability, weakness, control, countermeasure, and you can explore them then in the threat model. So you can figure out, well, I place this control or countermeasure in this part of the product to break the attack chain. So the threat actor is going, okay, well, I'll exploit this, and then I'll push that, and then I'll do this, and then I exfiltrate the data. So you can break that chain multiple places. And then that introduces the concept of security by design, by default, but also in depth, which isn't specifically mentioned explicitly in the CRA, but not relying on just one control. So the example we had about the multi-factor authentication, if the sensitive data that we're talking about is stored in the product, let's say it's stored physically, you may also layer up by having encryption at rest, so that if I physically steal the device and I pull the hard disk or the memory module, if I can, out of the device and I put it into another device, that I can't actually read it, it's encrypted. So that's two different weaknesses, maybe one threat actor. So if I can't guess your password and log in, it's got multi-factor, I go, okay, I'll pull the case open and I'll take the data out and I'll achieve my aims kind of that way. So that's kind of our thoughts when we're building our CRA-AI product, is we want to be able to ingest data from other sources, and then we want to be able to actually export it either through APIs, so that can happen through programmable interfaces, or that it can come in flat files, so you export something from
Actually, we are looking for.
Thanks. I hope you found what you're looking for. It's a lyric from a U2 song. So yeah, and what do we mean a bit by this? So once you've built the model inside the software, one of the things you'll want to do if you've decided we've got this controller or countermeasure is to test the controller countermeasure. So one way to do that is to have a third-party company do some kind of a vulnerability assessment or a penetration test against the platform. So that might happen externally, say, to our software platform, and within our consortium, we have such a company. So we're actively working on exporting the information from our platform into that pen test platform. The tests are conducted, and then what comes back to our platform, was the test successful? Tick, was it green or was it red, or was it amber? And if it's not green, did the retest fix it? So we don't actually really need to know exactly what the test was. We just need to know that the test results were positive from that other provider who holds that deeper data inside their kind of platform. So that's sort of some of the evolving thoughts we have in CRA-AI, and I'll get on to the AI bit as to why this is also important. But I don't know, Razvan, have you anything to add on machine readability or that type of stuff?
Thank you very much, Connor. Thank you for bringing this topic to the table. It's something that we are very much interested in, and we are also looking into how this can be can become a common practice and a point of reference for the industry. We feel that this element of having statements that are verifiable, where you can actually show, okay, I have placed this particular technical control, and this is the instrument that I've used in order to verify that it works. It would help quite a lot both manufacturers to know that the product they are putting on the market has passed some sort of a security check. It would also add additional assurance to customers, and it would also make, I believe, the life of and this is an assumption that I'm making now, but I would imagine that the Market Surveillance Authority receiving this type of information, ingesting this type of information, could quickly identify whether at least the major elements that relate to essential security requirements have been covered to practical testing by using specific tools, and that you can also showcase what the configuration of those tools that were used was at the moment when the product was released. I think that would bring a lot of added value. And also, as you pointed out, if this sort of ontology would be created and we would have a reference schema for a machine readable format, it would most likely, I would imagine, create an ecosystem of all sorts of entities that could support various parts of this testing process. So maybe some of those tests you can do internally, others you can do using third parties, and it would add an additional layer of assurance to your potential customers. Thank you.
Thanks, Razvan. And yeah, I think kind of that also maybe touches on a slightly different point about sort of the files that you need to actually maintain once the product is placed. So you could be asked for them by the Market Surveillance Authority, and some of that information would be what tests did you conduct to verify that the security controls or the countermeasures in the product were functioning as intended. So the second part kind of to this is sort of the AI part. So in order to support SMEs through this journey, what we intend in the software is that because things can come in a machine readable format, because we can then put them into a graph structure and extract the knowledge and put that into a graph structure, it provides, again, in a programmatic way, the context of the product so that we can actually potentially leverage AI technologies to do some of the work, the analysis, either for helping to define, for example, control tests, or looking at test results and validating if the test results match the original defined control tests, helping with that evidence locker feature that we want, which is putting into that evidence locker that information and kind of time stamping it so that it can be seen historically, what was done and when was it done, and you have all of that kind of available all the way out to helping to write user documentation. So generative aspects of large language models, which is not exclusively AI or the broader category of data science. The state of the art, we think, allows for some of that kind of capability to be embedded in the software itself to support the SME on the journey, because we're very conscious that in the call that we responded to, it did have an emphasis also not just on SME but micro and small. I think it's micro and small SMEs, which means you're a small medium enterprise, but you're a very small medium and enterprise, because some SMEs can be reasonably sizable. So not having direct access internally to cybersecurity expertise, so that the platform can bring some of that capability. But that's only possible, again, if we have ontologies, things are interoperable, things are machine readable. That really, really just helps. So we'll be pushing to sort of create those standards as a community, either through the project or through any other further initiatives to help sort of build that out. So that'll be part of what we do. Okay. I think from gases, we have, you're quite right in the legislation itself. It's intended purpose. I tend to use the vernacular of intended use. It just seems more understandable, but intended purpose. It's not exclusively to that as well, because there, in the essential requirements, for example, there is in Annex 1, there is one of the sub bullet points under that is about also to the mirror botnet point that Razvan made is to limit the harm to other devices or other products as well. So not to allow your platform to be a vehicle to attack other platforms, which doesn't really set under that intended purpose or intended use. Another question from Rose: how CRA is dealing with self-assessment testing exactly? I presume OSS is open source software.
Yes, that's correct.
Yep. So there is another project that was approved. That's part of, we're clustering as the projects that were approved on the call, called Octet. They're focusing a lot on open source software and open source libraries and the stewardship and all that goes there. And they're trying to create a platform that will allow open source projects to put that information that we talked about, hopefully in a machine readable format, not to emphasize the point too much, that lets, so rather than have lots of people trying to talk to the project, they'll put that information onto whatever platform Octet produces, so that you can get that information from the open source project itself. So we're hoping, again, maybe we can integrate there if it's all in kind of interoperable format. Intended purpose. It is. Yes. And this is part of maybe through the standardization work, is the regulation is a legal piece of text. So often it's not as consumable by normal human beings. there are people on the JTC Working Group 9 who are lawyers who specialize in this area. But yeah, I think maybe making it a little more accessible, either through the standards or through examples or explanations. Maybe if we move to the next slide. So this hopefully will be, the last 20 minutes will be quite interactive, and we'll leave some time for Q&A. So I just have a very bare bones example here, and I'm going to ask people to maybe propose some potential risks or events associated with this, but I'm just going to describe the product ecosystem that I've invented here. So this is a home security system, so intended for personal use in the home. So you've, starting at the very top, I'll work clockwise. We got that way. So you've got an indoor camera at the very top there. So that's a camera you can place on a countertop or a table or something like that internally. You have a sensor, so that can sense movement, for example, or if a door has been opened. I've represented the remote data processing as the next item. So that's a remote cloud-based service that something will interact with. Then at the bottom in the sort of 6 o'clock position is the basically a hub. So the indoor camera and the sensor will talk to the hub. It's sort of the way that they kind of connect in terms of information flows. And then they can flow out through. In the middle there is representation of the home Wi-Fi system, which is then the way that you connect out to the remote data processing solution. The next one going around is a mobile phone app. So again, that's connecting through the home Wi-Fi to the remote data processing solution to be able to, example, interact with video feeds from the indoor camera or to see sensor alerts from the sensor. And then the last one is actually an external camera. So another camera, but a camera you might fix to outside your property, looking at a driveway or a front door or those type of things. So this is a very typical product set. So maybe I could ask if anybody wants to have a go at thinking about what some of the risks might be associated with a product set. If I was to purchase all of these and then deploy them into my home, what kind of risks might I introduce? I'll do a starter for 10. I might ask Razvan then to do the next one, and then we'll see if anyone else. So if we're thinking about this as a home security solution and it's supposed to protect me, one of the risks could be, well, if you've disabled the system, if you've knocked it out, I'm not protected anymore. So if you've disabled the cameras and the sensors, then if you were to intrude into my home, I'm not going to see you or sense you. So a denial of service or some kind of thing means the objective of and the main feature of, you know, monitoring the home is no longer possible. And vectors for that as a threat actor would be I could disrupt the Wi-Fi connections. If there was a wireless cameras and wireless sensors, I can do an EMP style, which might be a bit excessive, but I can interfere with the electronic communications between the home hub and sensors for long enough while I'm doing it. I could compromise the remote data processing solution, so it's a threat to the remote data processing solution interrupt feed. Go ahead,
Connor, we have a question in the chat. I think this is a really interesting moment to introduce that difference between operational risk assessment and product risk. So, for example, in this case, going back to what you presented a few slides ago, this is not about looking at the assets. You look at the features, you look at the operational environment where you will deploy the camera. So, for example, one question, is the camera going to be deployed indoors or outdoors? Do we have a microphone or not? Is it going to be used in sensitive environments or not? And then, for example, you would look at a couple of security properties related to confidentiality, integrity, and availability, and you would start reflecting. Okay, so let's imagine that someone would take over the camera, right? So this is confidentiality, and the camera is deployed inside your house. Now, for example, you look at the microphone. Can the microphone be open in any circumstances? Do you have a switch on, switch off type of feature there? Do you need to authenticate to enable that particular feature? If we look at integrity aspects, can the feed be hijacked? Can I stream as an attacker a different set of video besides that being captured by the camera? Is that possible? When it comes to availability, and I think this was correctly covered by Connor, can I turn off the camera if I'm an attacker? Can I hijack the signal? Can I perform any sort of action if, for example, if the feed is being sent over radio and it's and there's no direct cable connection to the device? So there are all these questions that you would normally need to ask yourself and see what type of controls you would put in place in order to keep those features and also security properties of the device based on how you would imagine that a particular customer would be using your product. Connor, I'm passing this back to you.
Thank you, Razvan. Yeah, absolutely spot on. So you can see why Razvan works for ENISA. He's an expert in this area. And yeah, absolutely. I think Stanic's question, you're right, is for me, we're still often leaning towards thinking about operational risk because that's where most of our time has been spent as a cybersecurity community, and that shift into product security mindset it can be a bit tricky. Yeah, I think so. I think you're talking about all the different features, and then if we were to take a step forward on that, then the testing. So how would we go about testing this? So we've decided, okay, actually there's a step before that, the countermeasures controls. So we're using encryption, for example, from the cameras and the sensors to the home hub, so that we're actually to that integrity point, we're protecting the integrity in transit. So how would we test that? Well, we need to build a lab, we need to intercept the traffic, we need to look at how keys are being managed and being initialized. So again, that's security by design and by default. How am I syncing the camera to the hub, and is there any weaknesses in there that I could like force a handshake and do a man in the middle attack and so on and so forth. And this is where the threat modeling comes into play, and as we decompose that, and then there's the elements of the software running on the hub. So I may be getting that software, I think, to Rose's point earlier, that might be an open source piece of software. It may be running an open source operating system, for example. So that's not mine. I need to get that SBOM from that project because I'm responsible for the security. But in terms of maintenance, that's not me. That's somebody else. So that's my upward supply chain. As the manufacturer selling this product, I've got a supply chain kind of behind me. Yeah, so that threat modeling brings out all of those different kind of threat aspects, and yeah, the CIA triad is a really good way to think about them. And then I'd be doing the testing, and then I'd be thinking about writing the user documentation. So if I was explaining how to initialize the system, I'd be explaining, okay, you need to plug the hub in, turn that on, the LED needs to be flashing. You now need to go and do the same with the camera. That will handshake in the user documentation, and that's protecting you from the risk of somebody intercepting your feed because we're encrypting the information flowing from A to B. So if we think about the user documentation aspects, that's where that would come in. And this seems like a simple system, but when we sat down and decomposed this is complicated. It's not straightforward because there's components and subcomponents. There's software that's made by the manufacturer directly, software that's not made by the manufacturer, and then there's the whole aspect of the remote data processing, and where does that end, and what kind of security needs to be there too. So even something that appears to be simple, we found actually there's a good deal of complexity in it, and it's more difficult, I think, than we thought when we started out on this journey with the project. I don't know. Back to you, Razvan. Is there anything else you wanna add there before we go to Q&A or take any other points?
I'm somehow reflecting on this last statement that you made, that something that looks simple is actually quite complex. And I do hope that people will not leave the webinar with the feeling that the CRA is going to make their lives very, very difficult as manufacturers if we have such representatives in the call with us. I think if we look at the history of software development, in particular, at the development of what we call patterns and anti-patterns or dark patterns, we will most likely see a lot of this, what looks like an upstream hill being chopped down rather fast, as some of these best practices will emerge for many of the manufacturers, because no one wants to reinvent the wheel. Many of the elements that you have described now can be fixed by applying some of these well-established patterns in terms of playbooks. Also, you have quite a lot of libraries right now that come with a lot of security by design principles embedded in them that go through a lot of fuzzing, and we see that in the case of quite a lot of the big software manufacturers. They do have this experience. I think now the question mark is whether that experience is going to percolate across the whole ecosystem. And here is where I think guidance and help will be needed, because the know-how is there. The question is how it can be embedded across the complete ecosystem. Thank you.
Yeah, thanks, Razvan. And actually, there's two really good questions I think that help there. So detailed standards on the risk assessment, yes, they're coming. They're part of that 47 kind of standards to a standard to conduct the product orientated risk assessment. So that's going to help for sure. So that'll be again available in 2026. And I think also the point about, a lot of these products do fall under red, absolutely. So given that it comes into effect in August of 2025, which is not far away, some of the complexity I talked about actually will hopefully, to the point in the chat, go away, because when we started this back in January, the amount of documentation you get with these components is relatively light. So when we started decomposing this, we were running into questions, okay, well, what's inside that home hub? Well, we don't get a description of that. So the only way to figure that out is to start actually talking to the manufacturer, go through their supply chain and figure out what this thing is made of. I think to the earlier point about interoperability, machine readable formats, if that product came with just, here's the bundle, here's the S-bomb, here's the H-bomb, there you go, you can absorb that in quite quickly, then that leads itself to that threat modeling being much, much easier, because you've got that kind of breakdown of all and that flows back into the supply chain. So in certain cases, there's the primary manufacturer, we think, who's selling to the customer, and then they may have sourced components from lots of different places to assemble that kind of product. And some of them, the things we're thinking about is, for example, I may be able to buy the home security system, but not buy the external camera day one, but day two or week 3, or in the future, I buy the camera and I add it to the ecosystem. So we're also thinking about product ecosystems as well as just individual products, and back to that definition of what constitutes the product. So again, if there's a secure initialization process, for example, for the camera, then all the cameras should leverage that same process. You shouldn't be, or it doesn't make sense to actually mix and match. Question then about if the company is ISO 27000 certified. So this is a really good question, and it's one I think that comes up a good bit. So ISO 27000 is an operational information security management system. So that's for your operational environment. There is a question, actually, we put a blog post on it, is that does the CRA explicitly or implicitly, implicitly as opposed to explicitly, implicitly say anything about the manufacturing environment? And we think there is something there, because how can you guarantee the security of the product and it's free from vulnerabilities if the environment in which you manufacture it is insecure? So operational security may have a tangential, but I think for the purpose of product security, it's quite different. And there are other standards, obviously the ones coming from CRA, but there are standards in, for example, the OT area that kind of give that product-led security standard. I'm going to pause there unless there's any more questions, because I think Andrea is going to remind us what we need to do post the webinar.
Yeah, we are a bit running out of time.
Yeah.
So to wrap up, here are a few practical steps you can take right after this webinar. First, we recommend you complete the CRA readiness assessment. This will give you a personalized report outlining your current status and provide you with a step-by-step Cyber Resilience Act guide. And if you're an SME, you can request a free access code by emailing us at this email here. I will also put it in the chat. Secondly, consider joining the early adopter program. You will get access to the AI compliance platform and help shape its development with real-world input. You can register. Also, I will let the link in the chat. Also, feel free to explore more on the project website and follow us on LinkedIn for updates, tools, and upcoming events and webinars. These steps will help you prepare early and stay ahead in your CRA compliance journey. Thank you so much for joining us today, Connor, Razvan. Very useful insights. Thanks for your time and see you at the next webinar. Okay, I think we have one last question. Axel, you can open the mic and say it.
Sorry, that was the wrong button. Appreciate the webinar. Excellent. Thanks, guys. That was awesome. Thanks.
Thank you very much.
Yeah, and thank you for everybody for attending. Take care.
You made me hitting the wrong button.
Okay, thank you.
Bye.
Thank you.
Bye-bye.
Bye-bye.
Have a great day.